So going back over naming this particular molecule, we are looking at step one is trying to identify the parent chain, the longest carbon chain in the molecule. Now, you can play around with the numbering. Start from one end to the other. Like for instance, I could go like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I could also go from this aspect the other way. I could go down here, 9, 10. I'm just looking for the longest chain. So I could go left to right, right to left, but now I have to ask myself, where are the branches, the groups that come off of the main chain? Where are they located? Because I want to put as many of them on the lowest numbers of the main chain as possible. So if I'm looking up here, the blue going left to right is better because that would give me this group right here off of the 3. That's one of our branching chains. Or if you wanted to identify this one as the branch, you could. It doesn't really matter if this is 1, 2. They're both going to branch off of the 3 anyways. So we have this one. This is at 5 and this one's at 6. If I went the other direction, this one would be on the 5, this would be on the 6, and then this one would be off of the 8. So going left to right actually puts them on lower numbers in general, or one of them on a lower number because it's on 3 instead of 8. So I am going to number it left to right. And also in this kind of pre-planning stage, it's telling me my longest chain happens to have 10 carbons in it. So if my longest chain has 10 carbons in it, what is the name of the longest chain? Going back to those prefixes, it's going to be a decane. Yes, a 10 is going to be decane. So you definitely need to study over those prefixes again. Remember, the first 4 are different. It's meth, eth, prop, and bute are the first 4, 1 through 4. Then it goes back to the regular prefixes that you know. Penta, hexa, hepta, octa, nona, and deca. Deca like decade, there's 10 there, so like 10 years. All right, so we're good with that. So we've identified our decane here. Why, what happened to my thingy? There we go. So this is a decane. And I basically decided that numbering my carbon atoms from left to right puts more of the branches on lower substituent numbers off the main chain. Those substituent groups are going to be off the lower numbers. Remember, they're substituting in for a regular hydrogen, those branching chains. And there's 4 main ones that we're going to be working with. The ones with 1 carbon are going to be methyl groups. The ones that have 2 carbons are ethyl groups. Any that have 3 carbons would be propyl groups, and anything with 4 carbons would be butyl. So we're not going to go much higher than that with our substituent carbon groups. So it says number and putting the substituent branches at the lowest possible numbered carbons, which we did there. Now we're going to identify them and give each a number. Okay, the one it's connected to, identify them. So this one right here, here's off our 3rd carbon. This is our branch. 1, 2, so really this is like CH3, CH2, or if you look at the other chart, it's C2H5. In that particular case, 2 carbons is going to be an ethyl group. Now, how would we write this? Well, it's off of the 3rd carbon, so this would be 3-ethyl. Ethyl because 2 carbons, eth is the prefix for 2, so this branch is a ethyl group off of the 3rd carbon. We put hyphens, the dashes, in between numbers and letters. So in between numbers and words, you're going to put dashes. Now let's look at our next one. Off of the 5, we do have a branch here where it's only 1 carbon. And what do we name it if it's only got 1 carbon? one carbon, the prefix is meth, so it would be a methyl group. We just changed the ending to the YL. So this is a methyl group. It's off of the 5, so we would put 5-methyl for that group. We do have one more branch. Where is it located? Which carbon off the main chain? It's off of the 6th carbon right here. This one is also one carbon off of the main chain. That's going to be a methyl group. So this would be 6-methyl. All right, now, this is where it gets a little crazy. 2 or more identical substituents. You have to use a prefix with it. Now, I think this step is redundant, but what do I know? I didn't create the naming system. So we have 2 methyl groups. So this is how you would write it if you have more than one. If you have 3, you would write all 3 numbers and so forth. But since there's 2 groups here, we were going to do 5, 6, because there's one on the 5 carbon, there's one off of the 6 carbon, dash, and this is where you need the di part to indicate 2 groups, dimethyl. If it had 3 groups, it would be trimethyl. If it had 4 groups, it would be tetramethyl or whatever. Once again, I think that part's redundant because if you label 5,6-methyl, I would say it would be safe to assume that there are methyl groups on both, but this is the IUPAC naming system, 5,6-dimethyl. So now we have all of the branches identified and how to put them into the name. So this is what we're looking at here. We have the 3-ethyl, we have the 5 and the 6-methyl groups. These are going to be part of our names right here. Now we have to figure out how they go in what order. What order do they go in? Well, you have to list them alphabetically. List them alphabetically before the root name. And our root name is decane, by the way. That's the parent chain, the root name. We do not alphabetize the prefixes, so the di part does not count. You know, that di part up here, that does not count. Only the methyl part, the M, and the E here. So we're going to put them in order of alphabetizing. Ethyl comes before methyl. So we would write out first 3-ethyl. Dash, because now comes the other numbers. The next one alphabetically is going to be the methyls. So that's going to be 5, 6 dash dimethyl. And the last one to put on to the end is the root name. No spaces. So here follow the commas to separate numbers. Hyphens to separate the numbers from the words or the names or the letters. No space between the last substituent and the root name. So then I just add on the decane on the end here. So this IUPAC name is 3-ethyl 5,6-dimethyl decane. I know, isn't this fun? Now I know that's a lot to process, so let's just go through it one more quick time. Have it right here. Root name. We're going to number them and figure out the longest chain and the ones with the lowest substituent branches. So I go left to right here to get my 10 carbons. That puts one of the substituents off the 3, one of the substituents off the 5, and one of them off the 6 up there. Next step, of course, is label the root name as decane. So 10 carbons there. Identify substituents, give each a number. So the first substituent there is off of the 3rd carbon, which would be an ethyl group because it is a 2-branched one. So we have 2 carbons branching off of there. So that becomes an ethyl group. We also have a branch off of the 5, and there's only one carbon branching off of there. A 1 carbon group, that's a methyl group. We also have one branching off the 6 up there, so that's also a methyl group. Identify them, number them. Then combine anything that are identical. So identical ones combine and give it the prefix. So here we had 2 methyl groups, so it's got to be 5, 6 dimethyl. So that's the next step. Now list the substituents alphabetically. So ethyl comes first, then the dimethyl. So we're alphabetizing the root ones, not the di, tri, tetra part, not those prefixes. Then we are going to just list them in order. The ethyl, then the methyls, and then the root name. Commas separate numbers. Hyphens separate the letters or names. No space between the last substituent and the root. And it's nicely spinning up there for you. So we have the 3-ethyl, the 5,6 dimethyl, and then the decade. I tried to put it in color so you could kind of see how we're grouping it off as we put the name down. Now we're going to practice, so don't worry. We're going to have lots of practice in how to interpret these and how to name them. Let's start off with our first practice one here. Hydrocarbons, yay. All right, so here, first thing to do is start counting. How many carbons are there for that particular chain? 7. So this is a heptane. Does it matter which way we number here? No. Why does it not matter for this particular one that we don't have to worry about the direction of the numbering? It's just the one thing. There are no branches or substituent groups to consider here. There is no other thing branching off of it, so it's just the one parent chain. So really, this is just heptane. This one's very simple. You would just call that one heptane. But if you look at the one over here to the right, guess what? We definitely have branches there to worry about. So before you put anything completely down on paper, what you want to do is just number a few directions and see how it goes. So I kind of just play around with it. That's one way. I could do 1, 2, 3, 4, 5 that way. I could do, 1, 2, 3, 4, 5 that way. I could even do this, one of these. I could do 1, 2, 3, 4, 5. But if I look at my numberings, this one looks like the best where I want the 2 there because that's going to have branches off of there, and that's a low number to have the branches off of. So it really doesn't matter which one I choose. For some of our own sanity, it's probably better just to use the blue strand because that's like already in a line for us. So I'm going to use the blue strand as my numbering. But play around with it till you get the longest strand. How many carbons are in the longest parent chain here? 5. So our root name or our parent chain is going to be called what? Pentane. So I'm going to mentally remember pentane. I'm just going to jot it down over here that I'm going to need that later. This is a pentane. All right, now I need to consider substituent groups. Where is the first set of substituent groups? Where do they branch off of? Number 2. Good. And let's look at them. I have a CH3 and a CH3. What kind of groups are those CH3s? They're methyl groups, so this is methyl. Are there any other branches off of here? Yes, there's one off of the 4, so let's look at that one. The one off of the 4, there's also a CH3, so that's also a methyl. So that means we have 3 methyls here. Fun. So when we're writing out our substituent name here, the groups, the branches, I have 2 off of the 2 and 1 off of the 4. So this is how you would list it out. It's going to be 2, 2, 4. You have to put all the numbers down. There's 2 off, 1 off the 2, another one off the 2, and another one off the 4. Now, since there's 3 of them, what is the prefix I have to put in here now? Yes, this is going to be trimethyl. Trimethyl. And then, no spaces, I just add on the pentane here on the end. So this particular structure up there is 2,2,4 trimethyl pentane. It's okay if you haven't caught on yet, we still have more practice. So here, let's do some more. Oh, and I like this example too because it shows the shorthand version, because we've been looking at ones that are condensed structural formulas, been looking at ones that are like Lewis dot structures similar to the lower right one here. But this one right here with the sticks, the stick method a lot of the chemists like to use because it's faster and easier and less tedious. But what does it mean? Like if you look at that, you're like, I have no idea what that means. What it really means is that every corner is a C. Every part of the zigzag is a C. So this right here in the middle, though, is going to just be a CH, and I'm going to tell you why. If you look at the way that these are bonded, remember carbon does 4 bonds, correct? Carbon does 4 bonds. So if we're looking here at this particular point on it, that carbon is attached to a methyl group up here. It's attached to the methyl group over here. And it's attached to the CH2 group over here, this one. Well, we have to complete the octet with something. So, and since these are hydrocarbons, it completes the octet with 1 H. So you know how many H's to add on based on how many other bonds still need to be filled. It's already bonded to 3 things, so it only needs 1 H to fill the octet. Whereas one in the middle here, like this one right here, if you think about it, it's attached to another C on this side. So to fill this one, we just have to put an H up here and an H over here. That's why it's a CH2 group. This would be the CH2 group. Now they like the stick method, and you can adopt the stick method. You can do any particular way you like to draw them. But you can do the condensed structural formula one. I like that the best because that's the best way I do it. Drawing Lewis dot structures, though, get very long because you have to do every single H on it with the dashes and everything, with the lines. So I would stick to either doing the stick drawings or the condensed structural formula. So now that we kind of have a good idea of what this stick one looks like, let's go ahead and name it. Looking at it, just spot looking at it. Which way is the nut? Do you have a good idea of which way you should number it? Left to right or right to left? I agree, left to right, because it looks like more of the branching things going over there on the left. So that's where I would start. I would start over here. 1, 2, 3, 4, 5, 6. So that means I have, what's my root name there? That's a 6. 6 is going to be a hexane. Very good. So we have a hexane here. That's going to be our root name. So yes, very good. And it doesn't matter which one you number the one, because this one will be the substituent or this one will be the group. So we have one methyl group. Either one, it doesn't matter, are both off of this 2 here. So really, we just have the one branch. So that's going to be 2-methyl hexane. That one's a little more simplistic than the very first one we did. Now let's look at this one, this Lewis dot structure, mainly in the lower right corner. They did condense the substituent groups. Does it matter which way we number this one? Looking at it. No, because you can see that both substituents or both of the branches are off of the middle carbon right here. So we could go 1, 2, 3, 4, 5, or you could go the other direction. It really doesn't matter. How many are in this one? What's our root name for this particular structure? 5 carbons going to be 5 carbons is the pentane. Yes, 5-sided like the pentagon, pentane. Very good. So that's our root name. Now we have 2 branches to deal with. This one down here, the C2H5, what do we call that? That's an ethyl, and it's off number 3, so I'm going to write that as 3-ethyl. This one up here, I'm going to write it over here. CH3, what kind of group is that? A methyl, so I'm going to write 3-methyl. Only have the 2 groups this time. Which one comes first? Do I put the ethyl first or the methyl first? The ethyl, we alphabetize them. So ethyl comes before methyl. So yes, right here, this would be, let's see if I can write enough space it out good. 3-ethyl, 3, yeah, I guess there's 2 dashes there. 3-methyl pentane. 3-ethyl dash 3-methyl pentane. Fine. So you can always check here in the PowerPoint at any time and go back and look at them because they're in here for you. The answers. Now we're going to work backwards. We're going to start with the name and we're going to try to draw it. This is always fun. I think this is actually easier than trying to name it, but we'll see what you guys think. So if I'm looking here at butane, there aren't any groups off of it at the beginning there, so I don't have to worry about that. What do I need to just do here then? What does butane mean? It's got 4 carbons. So there are multiple ways you could draw this that would be acceptable. You can draw the Lewis structure. But this takes a while. As you can see, I have to put all the H's on separately. Not kind of fun. That's one way you could do it. 4 carbons, it's just a straight chain, it's only the parent chain, all of that. Or you could use the stick figures. So, like this is a carbon, this is a carbon, this is a carbon, this is a carbon. You could leave it like that too, you don't have to add anything. Or you could be like the way they do it where they put CH3 here and they put CH3 here. You could do it that way too if you wanted. The last way you could draw it is the condensed formula, and I like to do the condensed formula, so I'm going to draw it down here since I'm trying to show you all the ways you could draw it. 4 carbons. I like to leave space between them because then I have to add in the H's. All right, the ones on the end are going to need 3 bonds, like so, right? So the ones on the end are going to need 3 H's, so I just put the 3 H's in there. This one also is on the end, so it's going to need 3 H's. The 2 in the middle, they already have 2 bonds, so they only need 2 H's. 2 bonds, so they're going to need 2 H's. So that's another way you could draw butane. So 3 different options, whatever you feel most comfortable with, whichever one your brain processes the best. Kind of stick there. Now, let's go ahead and do 3-methyl heptane. I'm going to draw it in the structural form, the condensed structural, and I'll do the stick figure one because that's easy enough. So here we have 7 carbons. Ooh, I need space here, so I'm going to do it down here. C. How many carbons do I need to draw here? 1, 2, 3. How many do I need? I'm up to 4. What's a heptane? 7. So I need to draw 7. That's 1, 2, 3, 4, 5, 6. There's my 7th. Okay. Now, the other thing I have to focus on is what? This 3-methyl. Now I can go left to right or right to left. So say I decide to do right to left. This would be carbon 1, this would be 2, this would be 3. So this is the one I'd put my methyl group off of. So you could write it like that. You could go left to right if you want to go left to right too, and then you would put your group off of this one right here. That would be your 3 if you went left to right. Still would be acceptable. Now all I have to do is fill in my H's to finish off the structure. So this one on the end is going to need 3 because it only has the 1 bond. All of the ones that have 2 in the middle, like this one and this one, those are going to get H2s. However, look at this one. This one has 1, 2, 3. So how many H's should I put on it? Just 1 to fill out the last octet, so that's CH. This one's 2, so that's CH2. This one's CH3 on the end. This would be the condensed formula. Now, if you want to draw the stick figure one, you go 1, 2, 3, 4, 5, 6, 7. All right, so I start there. Now, it doesn't matter which direction you go, like I said. If you go left to right, your methyl group comes down here. You would draw it downward, and you just draw a stick. Or if you really want to, you could put the CH3 on the end. Doesn't matter. A stick, of course, also tells us it's a carbon. That's one way of doing it if you're doing left to right. And they zigzag them, and I'm going to tell you why they zigzag these is because all of these are tetrahedrals. It's like a big chain of tetrahedral shapes that have been linked together. So they zigzag them to show that because that's how it would look three-dimensionally. So those are 2 options. And like I said, left to right, right to left doesn't matter just as long as your numbering system makes sense. Let's do the last example up here. We have 2,3-dimethyl pentane. So how many carbons do I need to put in my construct to begin with? Focus on the root one. How many carbons should I put in my main chain, parent chain? 5. That's where I start. So I have like so. What else does it tell me? It tells me 2,3-dimethyl. So once again, it doesn't matter if you go left to right, right to left. I'm going to go left to right this time. I'm going to make this a methyl 2. This is going to be my 2. This will be my 3. So I can make my methyl here CH3. Now you could put them on the other side too. Doesn't matter, just as long as they're attached to the second carbon or the third carbon. So it doesn't matter which direction they're attached. Up or down's fine. Then all you have to do is fill in the rest with hydrogen. So this N1 gets a 3. This one's going to get a 2. This is 1, 2, 3. So this one just gets an H. This is a 1, 2, 3. So that gets an H. And then on the end here, it's the H3. That would be how it looks doing a condensed formula. And like I said, you could have one on the top and one on the bottom. You could flip the methyl groups. It doesn't really matter. If I wanted to do the stick figure one for that one, here I'm going to erase this butane, get it out of the way. Want to do stick figure on this one? I would go 1, 2, 3, 4, 5. Okay, in this particular case, we would want to put one off of the 2, so a stick off the 2 and a stick off of the 3. And if you don't like that, you could still add, the CH3s here if you think that looks better. You could add them on the ends. It really doesn't matter. You're going to see them. If you Google organic compounds, you're going to see lots of different variations in the way that they show the structure. And I put some answer key ones on here, and they're not even exactly, they don't look exactly the way that I drew, except for butane is fine. But you can see they zigzag these. But you can still, 3 bonds here. That's why there's only the 1 H. Same kind of system. This last one is very interesting because they're numbering it this way. This is 1, this is 2, this is 3, this is 4, 5, 6, and then the 7th. So this is the methyl group off of the 3rd. But that still works based off of the IUPAC rules.